Good morning, friends and dear students. I am here again for my course, Aircraft Systems. Today I am in lecture number 28, and the topic for the today class is control of fuel and airflow. As you know, my name is Dr. Yagya Dutta Dwivedhi, Professor from Institute of Aeronautical Engineering, Hyderabad, India. As of now, presently I am in module number 4, and this is my third lecture for module number 4, and this module number 4 is engine and fuel control system. So in my previous classes I have discussed about the engine control, that is FADEC, full authority digital engine control system. A glimpse I have given. In the second class I have described about gas turbine engine, how these turbine engines are working, what is the principle, and what are the theory behind the gas turbine engine of the aircraft. So if I talk about the module 1, module 2 and the module 3, in module 1 I have covered the 4 topics, major topics, and I have given only introduction of that. First one is the airframe system or structural system. Second one is the vehicle system. Third one is the avionics system. And fourth one is the mission system of the aircraft. If I talk about the airframe system, in airframe system we can divide it into the 3 groups. One is the wing system. Another one is the fuselage system. Third one is the empennage system. In wing system, we have the airfoil shapes, longerons, stringers, and so many other parts of the wing. In that, aileron, flaps, slats, these things are attached, which I have covered in detail in the topic before. Then if you talk about the fuselage system, in fuselage system I have covered the fuselage. I have divided into 4 groups. One is the canopy or the first group, then the center mid part, then the aft mid, and at the tail. Tail part is also called the empennage. Third component of the airframe system is the empennage. Empennage consists of the horizontal stabilizer, vertical stabilizer. In horizontal stabilizer we have the elevator, and in the vertical stabilizer we have the rudder. These systems we have to see and we have to take care of that. Now in module 2 I have taken the vehicle system. Vehicle system consists of number of systems, but in module 2 I have taken first the electrical power generation system, emergency electrical system, ram air turbine system, battery power system. Then I have taken the environmental control system, in which the temperature control, pressure control, density control, oxygen control, these things I have covered. We have oxygen control system where we will generate the oxygen or we will carry the oxygen on a bottle, and these bottles will be supplying the oxygen for the requirement, because we need the oxygen as and when we go at higher altitude. If you go above 8,000 feet and all, that time we feel some hypoxia, and in that we feel the shortage of oxygen and we feel uncomfortable. And if the person, a man who is in the less oxygen zone, their efficiency is going to reduce. So the pilots and the passenger, they have to take sufficient amount of oxygen so that they are very comfortable during flying, during operation of the aircraft. We have also seen the oxygen system, then firefighting system, anti-icing and de-icing system, oil system. These all things I have covered in module 2. In module 3, I have covered the two main systems of the aircraft, that is the hydraulic system and the pneumatic system. We know that so many components of the aircrafts, they are working under the hydraulic system. Hydraulic system gives the leverage. I have explained that time, by applying a very little amount of pressure, we can take the leverage and we can get the work done many times. As you increase the area of the piston and the cylinder of the output area, that much ratio. If assume we have 1 centimeter square input area, just I am drawing here like this, and if this is the output area and this output area is here 10 times. This is the 1 centimeter square, and if you have here 10 centimeter square, and if you press here with a 1 Newton of the force, it can lift this thing upward 10 Newtons of weight, it can lift up. So that is the advantage of the hydraulic system. Hydraulic system has got some special characteristics. It is incompressible fluid, so that effect of compressibility is not there. But if you use the pneumatic system, it is very cheap, but it is compressible and the accuracy of this system is reduced. So that is the disadvantage of the pneumatic system. And I have covered the brake system with the landing gear system, wheel brake system, flight control system, how they are operated by the help of hydraulic system. This I have already covered. Now in module 3. Now I am in module 4, and in module 4 we have the engine control and the fuel control. So we have to understand about the engine, then we have to understand about the control, then we have to understand about the fuel. And this topic says about control of fuel and the air. How the fuel and air is controlled, and how much amount of fuel and air has to be mixed with the system. So I am going to take in this topic. In today's lecture, I am going to take the history of the jet engine, working principle, components, and the thrust reversal. These are the few topics which I am going to take in this lecture. So I will go with the history of the jet engine, and if you see here, first person who has in 18th century, that is Sir Isaac Newton, in the 18th century was the first to theorize that a rearward channeled explosion could propel a machine forward at a great rate of speed. This theory was based on his third law of motion. As the hot air blasts backward through the nozzle, the plane moves forward. So if you see one, there is a balloon full of air, and here at the you put some pipe. Here is a pressurized air, and if you leave this thing, initially you have closed this and you by your finger, and if you leave, air will go out and your balloon will move forward. So this is the action and the reaction, and this was demonstrated by the Sir Isaac Newton on his principle, that is the third law of motion, that is the action and the reaction, and that he was able to explain how this can move if we put a exit, and after this exit the direction of the motion of this body will be opposite to this. So this is called action and the reaction. Then next person is Henry Gifford, built an airship which was powered by the first aircraft engine, a 3 horsepower steam engine. It was very heavy, too heavy to fly, but it is very difficult to fly because engine itself was very heavy. In 1874, Felix de Temple built a monoplane that flew just a short hop down a hill with the help of coal-fired steam engine. Then Otto Daimler in the 1800 invented the first gasoline engine. First, that is why it is called the Otto cycle. Otto cycle. So if you see in this Otto cycle, okay, it is a P and V. So it is a first is the compression, then it is constant volume fuel injection and the addition of the heat. This is the expansion, this is the compression, this is the Q in, and from here Q out. So this is the Otto cycle, and this Otto cycle was invented by Otto Daimler in 1800, invented the first gasoline or petrol engine. And this you can see the history here about aircraft engines. We have the W2/700 engine, flew in the Gloucester E-28/39, the first British aircraft to fly with a turbojet engine and the Gloucester Meteors. So first engine was used, the name of this engine is W2/700 and flew in the Gloucester E-28/39. This is the name of the aircraft, and this is by UK, England, and the first turbojet engine and the Gloucester Meteor. It is known. This is the piston engine. These two are the piston engine. A different. It is radial and it is in the axial direction. All the pistons are arranged in 2 rows. Each rows may have the 4 to 6 cylinders this side and this side, and this engine was also used in the initial stages of the aircraft flight. Now I will talk about the jet engine. A jet engine is an engine that discharges a fast moving jet of fluid to generate thrust in accordance with Newton's third law of motion. Just now I have explained. So jet engine is working in the action and the reaction. So the thrust is put outside, jet is put outside, aircraft will go opposite to that. So this principle was used for the jet engine. So what is the working principle? Jet engine are also called as a gas turbines. The engine suck air at the front with a fan. A compressor raises the pressure of the air. The compressed air is then sprayed with fuel and an electric spark lights the mixture. The burning gases expands and blast out through the nozzle at the back of the engine. As the jets of the gas shoots backward, the engine and the aircraft are thrust forward. So if you can see here that if you have something like this, there if you give some heat, this heat you mix with the fuel, it will burn. This high pressure and high temperature gases will move towards the nozzle. This is the nozzle, and from here they will go outside, and this whole body will move forward. So that is the principle of any jet engine. It works under the Newton's third law of motion, which says that there is for every action there is equal and opposite reaction. So this will make that the speed, how much speed the nozzle is throwing the gases, your nozzle along with the body will move opposite direction in the same speed if it is in vacuum. So this is the working principle of the jet engine. Now types of jet engine. We have the water jets, then motor jets, turbofan, rockets, and the ramjets. So these are the few types of jet engine. Water jet means water is filled and water is pressurized. If this is the water here, this is the water, and this water is pressurized, and there some, this is the opening. As and when you open this pressurized, a high jet will move in this direction and body will move. So it is a water jet. Motor jet means the motor will operate and motor will throw the water or the gases and it will go. Turbojet means, I will be explaining in detail about turbojets, turbofan, rockets and the ramjets. In turbofan, already I have explained that if you see the turbofan, turbojets. So in turbojets, just I will explain here. This is the shaft, then this is the inlet, this is the exhaust. Okay, so what will happen? Air will enter from here. It will go to the compressor. We have a number of compressor blades here. Then it will go to the combustion chamber. This pressurized air will enter. This is the flow, air flow. The topic is air flow. So we have to understand that. And some airflow will move above and it is not taking part in the burning. So only 30 to 40% of the air is used here in the combustion chamber, and from the injector, fuel is sprayed here, and from here one spark is used to give the ignition of this system, and this will burn. This burned gases will go and hit the turbine blades. Here the expansion will take place. Gases will expand and this will give a very high velocity to this, and there is a nozzle and this will give a high velocity exhaust and your aircraft will move opposite to this. This is the principle of the turbojets. If you talk about the turbofan, in turbofan, every item is same here except that before the compressor, we will have another fan which is this much bigger fan. This bigger fan will rotate with this shaft and some air will bypass from here and this will join at the exit. So here 50 to 60% of the total air is bypassed, and this bypass will go from the outer side of the core of the engine, which I have already explained in the turbojet, that the flow will go to the compressor, then combustion chamber. 30 to 40% of the air is utilized for the burning. Remaining 60 to 70% will go outside, and this will rejoin after the burning so that your engine is cooled down. Otherwise, the temperature will be approximately 2700 to 3000 degrees centigrade, and that much temperature the material may not be able to sustain and because the turbines are rotating with a very high speed, a lot of centrifugal and centripetal force will act on the turbine and lot of stresses will be developed, and with this much high temperature the failure of the turbine is likely to happen. To avoid that, in this type of system what will happen, the only 40% will enter to the core and 60% will enter to the fan. Out of this 40, only 10 to 15% will take part in the burning and remaining will go here. So the efficiency of the system is increased. Efficiency of the jet engine is increased in turbofan engine. So that is the purpose of the turbofan engine. Rockets engine, we use the fuel and oxidizer inside the chamber, and there the fuel will come and oxidizer will come, and these rockets are used for the space missions. These ramjets are used for the aircraft for a supersonic. If aircraft is flying with a supersonic speed, the missiles, which are supersonic missiles, are working under the principle of the ramjet. This ram, the air pressurization. In this, we don't have any moving part. Without moving part, only by the help of different types of nozzle, we are getting the pressure, and the exit also taken with the help of the nozzle. There is not even a single rotating part. By that, your system is moving, and this type of systems are used for the air to air missile or air to ground missile. This type of missile needs some initial boosting, which should go up to the supersonic range. If you are flying with the supersonic range, then this type of ramjets will work. So that is the principle of the ramjet. So I have just given a glimpse of the different types of jet engines used in the industry, and in our aircraft we use the turbojets, turbofan, turboprop, rockets, and the ramjets. These are used for the aerospace propulsion of the system. So here I will show here that working of the jet engine. Here I have given the diagram here, a basic diagram which shows the compressor. This one I will write 1, 2, 3, 4, and here this you can write 5. So if I draw the PV diagram of this, so it is intake. From here it will be compression. This is, I will write C. From here it will go for the combustion chamber 1 to 2, 2 to 3. Then it will go to the turbine again like this. This is the 4, and here it will be exhaust 4 to 5 or 4 to 1. Okay, whatever you say. So this is the Brayton cycle. For aircraft, it is not a closed one, so it will go to the atmosphere. So that is the difference between this. So here we have seen that we need one intake. So first, what are the components? What are the components we need? Main components of this, first is the air intake. This you can see here, air intake. Then we should have the compressor here. Then we have the combustor here. Then we have turbine. And after turbine, we should have the nozzles. Then we should have the fuel system. And then we should have the cooling system. So we need a fuel system and we need a cooling system. So these are the major components. But we should also have some intermediate components. These are called the turbo pumps, afterburner, and thrust reverser. So these are the three intermediate. These all are not there in all the engine. Only for a specific type of engines, these components are present. 2-3 components already I have up to this air intake, compressor, combustor, turbine, nozzle, fuel system. These are already I have explained in my previous class. But the fuel system, cooling system, turbo pumps, afterburners, reheat, thrust reversers, this I will be explaining. So this you can see that our topic is, if you see, what is our topic? Our topic is control of fuel and air flow. So that is our topic. So how this, we can see that, you see in this air intake, air is flowing from here. I am talking about the airflow, and here it is atmospheric pressure and atmospheric temperature. Both are entering in this combustion compressor. This pressure and temperature will be high. Here high, P and the T. At the high PT, it is entering in the combustion chamber. From here, fuel is injected, and here spark is given. Fuel is burned here. It will become at the point 3. You have very high P and T. Okay, temperature may be 2700 to 3000 degrees centigrade. Here at this temperature and pressure is entering in the turbine. But before that, I told you that this total air is not going for the burning. Only 40% is entering here. After this thing, few part of the air will go above this, and it will start cooling it is not burned. So it will start cooling the turbine blades. So in this way, air is also used for the burning. Air is also used for the cooling of the system. So here cooling system is required, and in the some air, and here the fuel system is also required, because we have to supply the fuel. I will be discussing in detail about the fuel system, and you will see that how these fuel systems are working on the aircraft. There are the turbo pumps also. Then we have the afterburners also. Then we have the thrust reversers are also used for the different purposes. Jet engine components, I have shown here that it is a turbofan engine here. So these are the fan. Then we have the compressor here. These are the compressor, turbofan. Then here is the combustor. Then we have here turbines, and it is size is increasing. If you see here, the compressor size is decreasing, but the turbine size is increasing, because it has to handle more volume. As the pressure and temperature is reducing, it will try to expand. So this has to be more. Then we have the mixture here. This mixture is used to mix the fluid of turbine and fluid of this area, which are coming from the fan area. They all will be mixing, and then all this will go outside, and this nozzle will give the speed. If we are using the convergent and divergent nozzle, it will be like this, and you are going to get high speed more than 1 Mach in the convergent and the divergent nozzles. So this is the airflow which I am talking about. Now I will talk about the component and its descriptions. First component is air intake, and I have shown here, this is the fan. If you see any aircraft engine, you will see like this. So here, this is the fan. These all are the fan here, and after that you will have the compressor. So air intake is passing through the fan. The fan is a first component in a turbofan engine. The large spinning fan sucks in large quantity of air. Most of the fan blades are made up of titanium. So this you have to remember, that most of the fan blades are made of titanium. It then speeds this air up and split it into two parts. So here it will try to speed up the air which is entering, and from here it will make one part 50% or more to bypass, go out of the core of the engine, and remaining will go from inside the core. So one part continues through the core or the center of the engine, where it is acted upon by other jet engine components. So this remaining part, just I will explain here again. So if I use here a fan like this, air is entering from here. So due to this rotation, it will increase the speed. But if you see here, this much part and this much part, approximately 40 to 50% of the air which is going in the inlet is bypassed from here. Remaining here 50% is entering in the compressor. Further we have another chamber. From here, if you see, here is the combustion chamber. Out of this 50%, again 20 to 25% is used in the combustion chamber, and remaining goes bypassing again. And this all air, here is the turbines. These airs are mixing in the turbine, this air, and this bypass of the turbofan will mix in the mixture here. Here we have the mixture. This mixture will allow to mix, and then it will go to the jet. So that is the function of our air intake and the fan. Next very important component is the compressor, and this you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there may be some 15 to 20 stages of the compressors are here. One stage means one rotating and one stationary. So like this, so more number of stages are there because it is axial flow compressor, and this axial flow compressor gives a very low compression ratio. Mostly this is 1.1 to 1.3. This is the range of compression for any axial compressor. So if we need a more pressure, so we need a more amount of stages so that the pressure can be achieved. So as you increase the stages, the size and the length of the aircraft will also increase. So that we have to compromise the weight, the size and other things. Then only we have to decide that what type of engine and how many stages of the compressors are required. So here I am talking about the compressor. The compressor is the first component in the jet engine core. But before that, there was a fan. So it is in the core part. And before the fan, air inlet is also coming. The compressor is made up of fan with many blades and attached to a shaft. The compressor squeezes the air that enters it into the progressively smaller area, resulting in an increase in the air pressure. This results in an increase in the energy potential of the air. The squeezed air is forced into the combustion chamber. So this squeezed air is with a very high pressure and temperature is used to burn the fuel inside the combustion chamber. So this we have to see that it is working properly. Now combustion chamber or the combustor or the burner. So I am talking about the different types of combustion chamber and their burners. So it is called the combustion chamber or the combustor or the burner. All are the same. So if anyone is asking anything, the same thing you have to explain. So what is the combustor? In the combustor, the air is mixed with the fuel and then ignited. So in the combustor, you see there are different holes, and these holes are properly designed so that a required amount of air and the fuel is required for the burning. So in the combustor, the air is mixed with fuel and then ignited. There are many as 20 nozzles to spray fuel into the air stream. The mixture of air and the fuel catches fire. This provides a high temperature, high energy airflow. The fuel burns with the oxygen in the compressed air, producing hot expanding gases. The inside of the combustor is often made of ceramic materials to provide a heat resistance chamber. The heat can reach up to 2700 degrees centigrade. This much heat it can be obtained. So here this you can see there are three types of combustion chamber: annular, can annular, and the can annular. So it is a annular, it is just a casing is there, only one part. Here we have the number of, you see here, it is a cans. This type of number of cans, 5, 10 are there. Inside it is burning. Here it is outside it is burning. But in this it is can is also there, and after that it is annular is also there. So it is called the can annular type. So this you can see here, it is a can. So like this number of combustion chambers are fitted like this. Here is annular burner liner. So it is a annular burner liner. So it is a annular and it is like this. So this one is like this. I can just show you, and this one is this. But nowadays we use can annular where it will be like this also, and inside this will be like this also. So it can take the advantage of the both this type of systems. Here this, you can see here is the inlet, then we have the compressor, then we have the turbine, then we have the nozzle, and this is the burner here, red color. And these red colors, either it will be this type or this type or this type. Any one type as per the requirement of the engine thrust and the efficiency of the engine. Normally we use the nowadays cannular type of engines we are using in today's age. Third important part is the turbine, and making of the turbine is very difficult task. Very precise systems are required for this. So here we have the turbine. So turbine, the high energy airflow coming out of the combustor goes into the turbine casing, causing the turbine blades to rotate. So this high pressure and the high temperature gases which are produced in the combustor, these combustor gases are hitting on the turbine blades. This you can see here, different blades are here. These are the blades. They are aerofoil shape. So they are used for the rotating. The turbines are linked by a shaft to turn the blades in the compressor and to spin the intake fan at the front. This rotation takes some energy from the high energy flow that is used to drive the fan and the compressor. The gases produced in the combustion chamber move through the turbine and spin its blades. So this is trying to spin the blades. Now next very important part is the nozzle. The nozzle is the exhaust duct of the jet engine. This is the jet engine part which actually produces the thrust for the plane. The energy depleted airflow that passed the turbine, in addition to the colder air that bypassed the engine core, produces a force when exciting the nozzle that acts to propel the engine, and therefore the airplane forward. The combination of the hot air and the cold air are expelled and produced at the exhaust, which causes a forward thrust. So this you can see I have shown here the different nozzles. Here we have the two nozzles. This you can see it is for the CD nozzles. These CD nozzles are used for the supersonic aircraft. So the hot burn gases from the combustor, they are hitting the turbine. Turbine is rotating and this will give a high amount of velocity for this pressure, and temperature will convert to the high velocity, and this high velocity will enter in the nozzle, and this inside the nozzle your gases will expand, and there is a mixture this is here mixture. These mixtures are trying to mix the bypassed air, the cool air and the hot air from the core of the engine. Both are mixed, and with a high velocity these are entering in the nozzles. This you can see different nozzles I have shown. This is for the Navy, because the Navy we need the nozzles to be rotated for the vertical takeoff, for the short landing and takeoff. The nozzles can be rotated, the vertical downwards, so it will be vertically it is going to take off, like Sea Harrier aircraft or the your MiG 29s and all, they can go up and down. So like this aircraft, your nozzles are very important important components which gives the different types of direction of the thrust. Now I have shown here some different types of nozzles. Here variable exhaust nozzle on the GE F404-400 low bypass turbofan installed on a Boeing F-18. This F-18 is a fighter aircraft, and this GE engine is used for this F-18, and this F-18 can be turned. It can go vertical takeoff and the landing, short landing and takeoff. All these parameters are achieved by the help of this nozzles. If you are able to turn the nozzle, another it is shown another engine here. This is also a different engine, and this is quite big engine which is used for the your space propulsion. Next, we have the turbo pumps. These turbo pumps are used for the rockets and missiles. For space propulsion, we use these turbo pumps. Turbo pumps are the centrifugal pumps which are spun by the gas turbine and are used to raise the propellant pressure above the pressure in the combustion chamber so that it can be injected and burned. So in the space propulsion, we don't use the rotating part much. So the pump is used to pressurize the propellant pressure. As we are using in aircraft, we are using the compressor. So we are avoiding this rotating part, and there is a pump which will try to, it may be the piston engine or the reciprocating pump which is pressurizing the propellant. Turbo pumps are very commonly used with rockets, but ramjets and the turbojets also have been known to use them. Some turbojets and some ramjets are also using the turbo pumps to pressurize its fuel to burn. Here this we can see, here we have gas generator, here we have here turbo pump, here is the turbo pump, here we have the thrust chamber, here we have the valve assembly. So this turbo pump, it is used to pressurize and it will give and it will be injecting here, and this is the exhaust. Okay, so this is the example of a turbo pump engine. Now I will talk about the very important component of the gas turbine engine, especially for the aircraft purpose, and all modern aircrafts are using the thrust reversal in engine. So how these thrust reversals are working and how many types of thrust reversal we can do, I am going to discuss in few slides of now. So this thrust reversal, also called the reverse thrust, is the temporary diversion of an aircraft engine exhaust or changing of the propeller pitch so that the thrust produced is directed forward rather than aft. This acts against the forward travel of the aircraft, providing deceleration. So for the jet engine, this we can see this, we can change the direction of the thrust. For the propeller engine also, we can change the pitch of the angle of attack. So it will try to reduce the runway length, and in place of going aircraft forward, it will try to stop the aircraft. So these are the purpose of the thrust reversals. Thrust reversals are very useful for the aircraft carriers landing, for low, small length runway, short takeoff and landing. This type of thrust reversals are very much essential. I am showing you one diagram of the thrust reversal here. This you can see the thrust is reversed here in this direction. In place of in this, now thrust is reversed. So the engine speed can be reduced all of a sudden. This type of aircrafts are used in Boeing and Airbus. They use for in case of emergency, thrust reversals can be used to stop the aircraft in case some runway is short length or there is some problem on the runway in between, so that these systems can work very efficiently. Now I will talk about the fuel systems of the aircraft. Apart from providing fuel to the engine, the fuel system is also used to control propeller speed, compressor airflow, and cool lubrication oil. So this fuel is not only for to give the burn and give the initial inputs to the engine, but also it can use the propeller speeds, compressor airflow, and cooling of the lubricating oil, or even hydraulic fluid also can be cooled by the help of the fuel system. Fuel is usually introduced by an atomized spray, the amount of which is controlled automatically depending on the rate of airflow. It also increases the energy extracted by the turbine, which drives the compressor even faster, and so there is an increase in air flowing into the engine as well. cooling system of an engine. So this air is used to cool. I told you again and again and again. So this compressors, and there is some bypassing of the air, and this bypassing is used to cool the engine. Cooling air then passes through the complex passages within the turbine blades. After removing heat from the blade material, the air, now fairly hot, is vented via cooling holes into the main gas stream. Covers plates are incorporated on the blades. This acts as a centrifugal compressor to pressurize the cooling air before it enters the blade. Another solution is to use an ultra-efficient turbine rim seal to pressurize the area where the cooling air passes across the rotating disc. So this you can see that air is entering, and here some part is going and the cooling this turbine. So that is the purpose of the cooling system of the engine. This turbine has to be cooled for the efficient operation of the engine. Now again I will talk about the thrust reversal and its types. So thrust reversal, also called the reverse thrust, is the temporary diversion of an aircraft engine thrust for it to act against the forward travel of the aircraft, providing deceleration. So thrust reversal are used as a deceleration. It is working as a brake to stop the engine, to stop the aircraft. Thrust reversal systems are featured on many jet aircraft to help slow down just after touchdown, reducing wear of the brakes and enabling shorter landing distance. So to avoid the wear and tear of the brakes, to reduce the landing length, shorter landing distance. Such devices affect the aircraft significantly and are considered important for safe operation by airlines. So most of the airline will prefer to the thrust reversal. There have been accidents involving thrust reversal systems, including fatal ones. So due to this thrust reversal also, some accident have happened, and very dangerous accidents also has taken place. Reverse thrust is also available on many propeller driven aircraft through reversing the controllable pitch propeller to a negative value. The equivalent concept for a ship is called astern propulsion. So it is also called the astern propulsion, means in place of going forward, your aircraft will try to go backward and try to stop it. So that is called the propeller type of thrust reversal. Here just I am showing the propeller driven aircraft. Propeller driven aircraft generates reverse thrust by changing the angle of their controllable pitch propeller so that the propeller direct their thrust forward. So this reverse thrust feature became available with the development of the controllable pitch propellers, which change the angle of the propeller blades to make efficient use of engine power over a wide range of conditions. Reverse thrust is created when the propeller pitch angle is reduced from fine to negative. This is called the beta position. So how these things are happening? Just it is the propeller here, and normally the propeller angle of attack is positive. But when we want that reverse thrust should be happen, we will make it to 0, and after 0 we will make to negative. If we start negative, aircraft thrust, in place of pulling forward, it will try to push back. So it will stop the aircraft. This is used for the aircraft landing. Propellers are very much used, and in this pitch change, variable pitch propellers are used. If the fixed pitch are there, this system is not applicable. So in variable pitch propellers only we are able to do this reverse thrusting on the propeller. Now if you talk about the jet aircraft, we have seen also some figures here, but further I am going to discuss about different types of jet aircraft thrust reversal. On aircraft using jet engines, thrust reversal is accomplished by causing the jet blast to flow forward. The engine does not run or rotate in reverse. Engine will rotate only in the same direction. Instead, thrust reversing devices are used to block the blast and redirect it forward. High bypass ratio engine usually reverse thrust by changing the direction of only the fan airflow. Since the majority of the thrust is generated by this section as opposed to the core, there are three jets engine thrust reversal system in the common use. First one is the target type. Target type that I will also discuss, and I will show the diagram in the next slide. Target thrust reversal uses a pair of hydraulically operated bucket type doors to reverse the hot gas stream. For forward thrust, these doors form the propelling nozzle of the engine. In the original implementation of this system on the Boeing 707. So this bucket type of system was first used in Boeing 707. In this, we can see here that it is a bucket type, and this you can see here, the bucket here. It is like this, it is opening in opposite direction, and your thrust will be in place of this, it is going towards the nose of the aircraft. This makes it will try to stop the aircraft, and your distance of the runway will be tremendously reduced. So this is called the target or bucket type. Target, and this is also called the bucket type reverser deployed on the tail engines of a Fokker 100. So this is the Fokker 100 aircraft. In this you can see here, this is the bucket or the target type of. In this, thrust will be in this direction, and in this direction it will try to brake the aircraft, and your brake which is applied on the wheel brake, the wear and tear of the wheel brake is tremendously reduced. So these are the functions of this any thrust reversal. The second one is the clamshell type. So the clamshell door system is pneumatically operated. When activated, the doors rotate to open the ducts and close the normal exit, cause the thrust to be directed forward. So here, this we can see here, we are putting some obstruction inside the exit, and this makes the clamshell outlet grating open outboard engine on a Rolls-Royce company turbofan of VC10. So here we are using another grate. So in place of going here, this you can see some air is entered in this direction and your thrust is reduced. Next is cascade type. The cascade thrust reversal is commonly used on turbofan engine. On turbojet engine, this system would be less effective than the target system, as the cascade system only makes use of the fan airflow and does not affect the main engine core, which continues to provide forward thrust. So in this, main core will give the forward thrust, but turbofan engines, the turbojet engines, this system would be less effective than the target system. So these systems are used. Next we have here cold stream type thrust reversal. This you can see here. We are using the cold stream, means the stream of the fan which is not taking part in the burning is used for this purpose. Now I have shown this some modern aircrafts, those are using thrust reversal. So this is the F-35 Lightning. It is a very modern aircraft, and it is invisible, or it is you cannot detect by the help of the radar. This is the F-22 Raptor aircraft, only US Air Force has got, and this is the Rafale. In this Rafale also we have used this type of thrust reversal systems. Next lecture I am going to talk about need for the power of takeoff and its types. These are the references which I have taken: Moyer and the Seabridge, Aircraft Systems, Mechanical, Electrical and Avionics Systems. Second book, I have taken Design and Development of Aircraft Systems and Introduction, AIAA Education series. These are the two books, and I have also taken from the Wikipedia and some other internet resources for this class. Thank you very much for joining this class. If any questions, any queries, you are welcome to ask to me in my this email. Okay, ydwivedi@gmail.com. You are welcome to ask. Please like and subscribe this channel. Hope you are doing well, and you encourage me also. If anywhere I have done some mistake, please let me know. I will try to solve. I will try to improve myself. Thank you very much for this class. Be tuned. Take my next lecture also. This will be related to the engines and their fuel and other systems. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.